Our world is built on ice, not just the ice we see today, but 30 separate ages of it, each a master sculptor of our destiny. This is the story of how 30 ice ages, from the dawn of life to the cusp of our modern era, did not just change the weather, they forged human history itself. By the end, you will see the entire sweep of civilization through a new lens, where climate is the invisible kingmaker and every cold snap a catalyst for revolution. We will uncover why a sudden freeze 12,000 years ago forced our ancestors to invent farming, and how a volcanic winter 15 centuries ago shattered empires. This is an epic detective story, tracing the fingerprints of frost on everything from the fall of Rome to the voyages of the Vikings. The question hanging over it all is simple yet profound. When the climate itself is the ultimate architect, what does that reveal about the true foundations of our world? Our story begins not with a whimper, but with a freeze of unimaginable scale. 2.4 billion years ago, the planet plunged into its first great ice age, the Huronian glaciation. For 300 million years, the world became a silent, glittering sphere of white, a snowball Earth where ice may have reached all the way to the equator. This was not just a cold snap, it was a planetary lockdown, a deep freeze that should have been a dead end for any fledgling life. Yet within this icy prison, a quiet revolution was brewing. The simple, single-celled organisms of the time, cyanobacteria, were beginning to do something extraordinary. They learned to harness sunlight to produce their own food, and in the process, they released a waste gas that was utterly toxic to most life on the planet at the time, oxygen. As these microbes thrived, they flooded the ancient oceans and atmosphere with this new reactive element. This great oxidation event, driven by life under the ice, permanently changed the chemistry of our world. It rusted the iron in the oceans, it stripped away the ancient methane that kept the planet warm, and this removal of greenhouse gases is what likely triggered the global freeze in the first place. So here is the profound paradox, the first great mystery of our 30 ice ages. The very process that made our atmosphere breathable for creatures like us also nearly killed the planet with ice. This primordial winter was the crucible. It created the oxygen-rich blanket we now depend on, and by wiping out many of the ancient oxygen-hating microbes, it cleared the evolutionary stage. It set in motion the conditions that would, billions of years later, allow for complex multicellular life for animals, for forests, and ultimately, for intelligent beings who would one day wonder about their own origins. Every breath you take, every society that has ever risen, owes a debt to that first epic freeze. The Huronian was the original reset button, the deep time event that made all future history, including our own, even possible. This planetary deep freeze was not a one-time event. Hundreds of millions of years after the Huronian ice finally retreated, Earth plunged into an even more extreme series of winters, a period so profoundly cold scientists named it the Cryogenian, meaning the time of ice birth. For nearly 100 million years, the planet endured a terrifying cycle of freezes so severe they likely encased the entire globe in ice, from the poles all the way to the steaming equator. Picture a world where the oceans are capped by a mile-thick lid of solid ice, where the only color is the blinding white of snow and the blue shadows of crevices under a weak, distant sun. This is the snowball Earth hypothesis, and the evidence for it is written in the rocks. Geologists find ancient glacial debris called tillites in places that should have been tropical, like the heart of Africa and the deserts of Australia. These are the fossilized footprints of glaciers that once crawled across the equator. But how could this happen? The leading theory points to a runaway feedback loop. As ice sheets grew, they reflected more sunlight back into space, cooling the planet further, which caused more ice to grow. The planet essentially locked itself into a global icebox. The debate, however, is fierce. Was it a solid snowball or a slush ball with thin ice or open patches of water at the equator? This scientific mystery is crucial because the difference between a snowball and a slush ball is the difference between a near-total extinction event and a severe bottleneck. For the simple, mostly single-celled life clinging to existence in the oceans, this was an apocalypse. Sunlight was blocked, photosynthesis nearly ceased, and the food web collapsed. These catastrophic freezes acted as the ultimate evolutionary filter, a bottleneck of unimaginable pressure. Life was forced into desperate refuges, perhaps around deep-sea volcanic vents or in thin cracks under the ice where a faint glow penetrated. This brutal winnowing had a profound consequence. It may have dramatically delayed the rise of complex, multicellular organisms. Before the freeze, evolution was ticking along slowly. After the ice finally melted, supercharged by volcanic carbon dioxide that built up under the ice and erupted to create a sudden super greenhouse, the stage was set. The genetic diversity that survived the deep freeze, now isolated and mixed in new ways in a warming world, exploded. This is the great irony of the cryogenian. By nearly wiping the slate clean, these global winters created the evolutionary pressure cooker that made complex life not just possible, but perhaps inevitable. If these ice ages had been shorter or never happened at all, the clock of evolution might have run faster. Animals, plants, even intelligent beings could have emerged hundreds of millions of years earlier. But they did happen, and by putting life on hold, by forcing it through the eye of a needle, these second great ice ages indirectly set the precise cosmic schedule for humanity's eventual, very late appearance on the stage. The planet's third great winter arrived 450 million years ago, a deep chill known as the Andean-Saharan Ice Age. This was a world alien to our own, a time before trees, before animals had crawled onto land. Life was almost entirely a marine affair, a bustling metropolis of strange creatures in shallow, sunlit seas. Trilobites scuttled across the ocean floor, giant sea scorpions patrolled the reefs, and early nautiloids with coiled shells jetted through the water. Then the cold came, driven by the slow dance of continents. The great southern landmass of Gondwana drifted over the South Pole. Ice sheets, thousands of feet thick, began to creep northward, locking up vast quantities of the world's water. Sea levels plummeted, not by inches, but by hundreds of feet. Imagine the coastlines of entire continents retreating mile after mile, exposing vast muddy plains where there had once been ocean. For the rich marine life of the Ordovician period, this was a catastrophe of habitat loss on a planetary scale. The shallow, warm, continental shelves that served as the cradle of biodiversity simply vanished, drained by the growing ice. This environmental upheaval, combined with a suspected plunge in global temperatures, triggered one of the 5 worst mass extinctions in Earth's history. An estimated 85% of marine species vanished. The vibrant, ancient seas fell silent. Yet within this tragedy lies a crucial geological legacy, one that would silently shape human destiny millions of years later. As those immense glaciers ground their way across the continents, they acted like planetary bulldozers. They pulverized mountains, scraped up ancient bedrock, and deposited this crushed debris in sprawling plains called glacial till. Within this till were concentrated the minerals and elements that had been scattered across the landscape. More importantly, the dying marine organisms from the extinctions sank into the deep, anoxic basins created by the changing ocean circulation. Layer upon layer of organic sludge accumulated, sealed under mud and sediment. Over incomprehensible spans of time, under immense heat and pressure, that organic soup would slowly cook into the coal, oil, and natural gas deposits we call fossil fuels. The very ice age that nearly ended complex life also meticulously packed away the solar energy of that ancient world, storing it in subterranean vaults. So when early humans millennia later discovered they could burn black rocks to keep warm, or when the Industrial Revolution learned to power engines with ancient sludge, they were tapping directly into the geochemical aftermath of this Ordovician Silurian freeze. The coal that fueled empires and the oil that powers our world are, in a very real sense, the preserved remnants of a climate-driven apocalypse that happened 450 million years ago. Our modern society is built, quite literally, on the frozen ruins of that third great winter. Yet the planet's climate machine was far from finished. 290 million years ago, as the ancient supercontinent Pangaea began to assemble, Earth descended into its fourth and longest winter, the Karoo Ice Age. This was not a brief cold snap, but a deep, persistent chill that gripped the southern hemisphere for nearly 100 million years. The vast landmass of Gondwana, which included what would become South America, Africa, Antarctica, India, and Australia, was centered directly over the South Pole. This perfect alignment created a colossal ice sheet, a permanent, crushing weight of white that sprawled across multiple continents. We can see its ghostly imprint today in the parallel scratches left on bedrock in Brazil, the distinctive glacial sediments found in India, and the ancient moraines preserved in the deserts of Central Africa. This ice age was a global sculptor on a slow, relentless grind. As the glaciers advanced and retreated over eons, they carved out deep valleys, planed down mountain ranges, and fundamentally rearranged the very soil and rock of the future southern continents. But the Karoo's most profound impact was not geological, it was biological. The extreme and fluctuating climates it produced, from icy expanses to the arid interiors of the new Pangaea supercontinent, placed unbearable stress on the dominant life of the time. The great swamp forests of giant ferns and early trees began to shrink. The changing atmosphere and habitats triggered the Permian-Triassic extinction event, the single greatest catastrophe in the history of life on Earth. An astonishing 96% of all marine species and 70% of terrestrial vertebrate species vanished. It was a near-total reset. In the devastated ecosystems that remained, the old rulers were gone. This cleared the stage for a dramatic evolutionary audition. Two groups of survivors saw an opportunity in the emptiness: the reptiles known as archosaurs, the ancestors of crocodiles and dinosaurs, and the smaller, furry synapsids, the ancestors of mammals. The harsh, post-apocalyptic world favored new adaptations. The archosaurs evolved into dinosaurs, creatures built for efficiency and dominance in a warmer world that would eventually follow. The synapsids, our own lineage, took a different path. They developed traits for survival in a harsher, more variable climate, including fur for insulation and a more active metabolism. So the Karoo Ice Age, through its brutal climatic shifts and the mass extinction it helped drive, performed a critical act of ecological engineering. It dismantled the ancient world order and created the vacant niches that the dinosaurs would spectacularly fill, setting the stage for their 160 million year reign. And in the shadow of those giants, it ensured our tiny, warm-blooded ancestors persisted, waiting in the wings for their own moment, which would come only after the next and most famous winter of all. The relentless grip of the Karoo Ice Age was not a constant, unbroken freeze. It pulsed in a slow, rhythmic beat of advancing and retreating glaciers, a climatic heartbeat that spanned tens of millions of years during the Carboniferous and Permian periods. These cycles of frost and thaw did more than just shape the land. They built the very fuel for modern civilization. As ice sheets periodically locked away the planet's water, sea levels would fall, exposing vast, low-lying coastal plains across the tropical regions of Pangaea. On these sun-drenched, soggy flats, a botanical revolution was taking place. Giant tree ferns, colossal horsetails, and the first true trees with thick bark and deep roots created dense, steamy forests unlike anything on Earth today. For the first time, plants had evolved lignin, a tough polymer that gave them the strength to soar hundreds of feet into the air. But here was the problem: nothing had yet evolved that could properly digest this new, incredibly tough material. When these giants died, they did not rot away as modern trees do. They fell into the oxygen-poor, stagnant waters of the swamp floors, piling up in massive, waterlogged mats of organic matter. Layer upon layer accumulated, century after century, compressing under their own weight. Then the ice would advance again, sea levels would rise, and these peat bogs would be buried under sediments sealed away from the air. This cycle repeated over and over, each pulse of the Ice Age adding another chapter to a buried story. The immense pressure and heat of deep burial over millions of years slowly cooked these ancient swamp layers, transforming that spongy peat first into lignite, then into bituminous coal, the dense black rock that burns with intense heat. These are the vast coal seams we mine today, the fossilized sunshine of a world that existed 300 million years ago. So when James Watt perfected the steam engine in the late 18th century and factories began to sprout across England, they were not just burning rocks. They were unleashing the stored solar energy of the Carboniferous, the geological legacy of an ancient ice age's rhythmic dance. The Industrial Revolution, with its smog-filled cities, clattering locomotives, and world-altering machinery, was powered by the compressed remains of primordial swamps that flourished because of a specific pattern of freezing and thawing. Our transition from an agrarian to an industrial society, a shift that defines the modern age, was fired in furnaces stoked with the very consequences of Earth's fifth great winter. The stage was now set for the final act, the winter that would directly shape us. Roughly 2.5 million years ago, the planet's climate crossed a threshold, entering a new and volatile state we call the Pleistocene epoch. This marks the beginning of the Ice Age as we popularly imagine it, a world of woolly mammoths and saber-toothed cats, but its true character was not perpetual cold. It was a relentless, rhythmic instability. For the first time in Earth's long history, the great ice sheets began to pulse in a regular, almost predictable beat, advancing and retreating across the northern continents in cycles lasting roughly 41,000 years. Imagine a colossal, frozen pendulum swinging across the globe. Each swing brought a glacial period where ice sheets over a mile thick buried what is now Canada, Scandinavia, and parts of the northern United States under a crushing white silence. Sea levels would plummet as water was locked away, connecting continents with land bridges like the vast expanse of Beringia, linking Asia and North America. Then the pendulum would swing back. A warmer interglacial would arrive, the ice would retreat in a roaring flood of meltwater, and forests would reclaim the tundra. This was not a single event, but a repeating drama of freeze and thaw. For any creature living through it, the world was not a stable home, but a shifting, demanding, and often dangerous puzzle. And into this puzzle walked our ancestors. Early hominins like Homo habilis and later Homo erectus found their African homelands subject to these powerful climatic swings. Lush grasslands would dry into deserts, forests would fragment, and food sources would vanish or migrate. This instability became the ultimate crucible for human evolution. Survival no longer favored specialization for a single, stable environment. It favored the ultimate generalist, a creature capable of relentless innovation. When familiar plants died out, they had to figure out which new ones were edible. When prey animals migrated, they had to track them or devise new hunting strategies. When the cold pushed south, they had to control fire, create shelter, and sew clothing from animal hides. Each glacial pulse was a brutal exam. And the prize for passing was not just survival, but a sharper mind, more complex social cooperation, and the ingenuity to walk into new, uncharted lands. The rhythmic advance and retreat of the ice did not just change the scenery, it forged the very toolkits of adaptability, curiosity, and resilience that would become the foundations of human nature. Our intellect is in many ways the cognitive imprint of the Pleistocene's icy pendulum. The Pleistocene's icy pendulum swung with a brutal new rhythm, and its first great push into Europe is named the Gunst glaciation. This was not a gentle cooling but an invasion, a slow-motion flood of ice that swallowed the Alps and sent glaciers crawling into the lowlands of Central Europe. The world became a place of howling winds, sparse tundra vegetation, and immense herds of cold-adapted megafauna like the woolly mammoth and steppe bison. Into this harsh new world walked Homo erectus, our upright, tool-using ancestor. They were not in Europe by chance. They were likely following the very animals they hunted, pushed north by changing African climates or exploring new routes during a slightly warmer interlude. The Gaunt's cold maximum was a filter of raw survival. To persist here required more than simple scavenging. It demanded foresight, the ability to process hides into clothing and shelter, and the social cohesion to coordinate hunts for massive, dangerous prey. The stone tools from this period, the robust hand axes of the Acheulean tradition, are more than artifacts. They are the fossilized decisions of intelligent beings solving problems of butchery, woodworking, and survival under immense pressure. When the ice finally retreated, it left behind a transformed landscape of deep U-shaped valleys and rich glacial soils, a temporary paradise that lasted until the next winter arrived. That winter was the Mindel glaciation, often considered the most severe of the Pleistocene in Europe. The ice sheets reached even farther south, and the permafrost line crept deep into the continent. This was a world pushed to its cold extreme, a true test of endurance, and here the fossil record reveals a critical transition. The hominins weathering this deeper freeze were no longer Homo erectus alone. By the time of the Mindel, a new, more robust lineage had emerged, one uniquely sculpted by the ice, the Neanderthals. Their very bodies were adaptations to the glacial climate, with shorter, stockier builds to conserve heat, larger nasal cavities to warm frigid air, and a metabolism tuned for a high-protein diet from hunting. The Mindel selected for more than just physical traits. It demanded unprecedented levels of cooperation and technological refinement. Evidence suggests Neanderthals were building more structured shelters, perhaps using mammoth bones and hides, and they were mastering the use of fire not just for warmth but as a central, protected hearth for social bonding and food preparation. Surviving the Mindel was not about brute force, it was about communal intelligence and the careful curation of knowledge across generations. After the Mindel's retreat came a long, complex interglacial, a period of forests and relative warmth that allowed populations to grow and spread. Then the pendulum swung once more with the Risse glaciation. While not as severe as the Mindel, the Risse was vast and enduring, its ice sheets blanketing much of northern Europe and Britain. By this stage, the Neanderthals were the undisputed masters of glacial Europe. The Risse presented a different kind of challenge, one of persistence over millennia in a consistently demanding environment. Their toolkits, the Mousterian technology, show remarkable efficiency and specialization, with carefully prepared stone cores that produced consistent, sharp flakes for specific tasks. This was not haphazard toolmaking, it was planned, economical, and passed down through precise cultural teaching. The Risse filtered for deep environmental intimacy, a generational knowledge of migratory patterns, seasonal resources, and the subtle signs of a changing landscape. It fostered a culture that was resilient, deeply connected to the rhythms of the Ice Age world, and capable of complex symbolic thought, as suggested by potential burial practices and the use of pigments. The Gaunt's, Mindel, and Risse were not just cold periods, they were a sequential training ground. Each glacial maximum posed a unique set of problems, and each solution, etched into stone and bone and eventually into the very DNA of its survivors, added another layer to the foundational skills that would define humanity's capacity to conquer a volatile planet. Across the Atlantic, the same global chill that brought the Risse glaciation to Europe was sculpting a continent on an even grander scale. This was the Illinoisan glaciation, the most extensive southward push of ice in North America's history. At its peak, the Laurentide ice sheet was a monstrous dome of white, over 2 miles thick in its center, crushing down upon what is now Canada and the northern United States. Its southern edge did not stop at the Great Lakes. It bulldozed far beyond, reaching into present-day Illinois, Indiana, and Ohio, leaving behind the characteristic rolling hills and rich soils that would one day feed a nation. The sheer weight of this ice was incomprehensible, so immense that it literally depressed the continent's crust beneath it, and as it advanced, it was not a clean sweep but a slow, grinding excavation. The glaciers acted like cosmic chisels, scouring out deep, pre-existing river valleys with the relentless force of billions of tons of moving ice. These gouged-out trenches, filled with meltwater as the ice eventually retreated, would become the basins of the Great Lakes. So the very geography that defines the industrial and ecological heart of North America, those vast inland seas, are the direct scars of the Illinoisan winter. This frozen barrier fundamentally rewrote the map for every living thing on the continent. For the megafauna, the great herds of mammoths, mastodons, and giant bison, the advancing ice wall severed ancient migratory corridors and compressed populations into a narrow, ice-free corridor between the Laurentide Sheet to the east and the Cordilleran Ice Sheet over the Rockies to the west. This created a bottleneck of life, a crowded refuge where competition was fierce and predators thrived. And into this dynamic, challenging landscape came the first human explorers, the Paleo-Indians. The traditional story suggests they crossed the Bering Land Bridge from Siberia into Alaska during a period of lower sea levels, but the way south was blocked by a continuous wall of ice for millennia. The retreat of the Illinoisan glaciation, however, did not simply open a door, it created a specific pathway. As the two massive ice sheets began to pull apart, they left a long, navigable corridor between them, following the eastern flank of the Rocky Mountains. This ice-free corridor, emerging from the meltwaters and glacial debris, was not a hospitable highway, but a harsh, newly exposed landscape of glacial lakes, rocky rubble, and sparse vegetation. It was a race against time for plants and animals to colonize it, and for humans to follow that trail of life. The peopling of the Americas was not a single event, but a process intimately tied to this glacial retreat. As small, highly adaptable bands of hunters tracked the mammoth and bison herds through this precarious corridor, they were walking a path carved by the ice's slow surrender. Their survival depended on a deep understanding of this post-glacial world, of where to find fresh water in the meltwater channels, and how to predict the movements of game in a landscape still raw and reforming. The Illinoisan glaciation, therefore, was more than a geological event. It was a continental gatekeeper. Its advance sealed the continent off, and its carefully timed retreat provided the precise, narrow avenue through which humanity finally entered and populated two vast continents. The story of the first Americans is at its core a story of human ingenuity meeting a world freshly made by ice. But the Pleistocene had one more brutal lesson to teach before the final act. Roughly 150,000 years ago, the climatic pendulum swung into its penultimate and one of its most severe positions. This was the stage before our current interglacial, a deep freeze so profound it is known simply as the penultimate glacial maximum. Global temperatures plummeted, perhaps 10 degrees Celsius colder than today on average. The northern ice sheets expanded to their near maximum extent, and aridity gripped the continents. Deserts expanded, rainforests shrank into tiny pockets, and the world became a drier, dustier, and far more challenging place. For the ecosystems of the planet, this was a period of intense stress and compression. Vast swaths of habitat simply vanished, forcing surviving species into isolated refugia, small pockets of relative hospitality where they could cling on. And for our own species, Homo sapiens, which had emerged in Africa around 300,000 years ago, this glacial maximum presented an existential crisis. The genetic evidence tells a startling story. By analyzing the diversity in our modern DNA, scientists can trace our ancestry back to a surprisingly small population that lived through this period. The data suggests that sometime around 150,000 years ago, the total number of breeding Homo sapiens may have crashed to just a few thousand individuals, perhaps even fewer. We were not a thriving species on the verge of global conquest. We were an endangered one, teetering on the razor's edge of extinction. The penultimate glacial maximum had likely pushed us into our own refugia, confined to a handful of hospitable zones within Africa. Imagine small bands of people clustered around reliable water sources, perhaps the Nile Valley, the coasts of southern Africa, or other scattered oases where game and edible plants could still be found. These were not communities in the modern sense, but fragile threads of survival, separated by hundreds of miles of inhospitable desert or frozen grassland. They were living in a world that seemed to be actively trying to erase them, yet within this desperate confinement lay the seeds of our future. Survival in these refugia demanded the absolute peak of our cognitive and social abilities. Cooperation wasn't just beneficial, it was mandatory. Sharing food, caring for the young and injured, and maintaining complex social bonds across a tiny group meant the difference between life and oblivion. Language likely became more nuanced to convey detailed information about scarce resources or distant dangers. Innovation in toolmaking, perhaps using smaller, more refined stone blades, would have been essential for efficiency. This glacial bottleneck was a forge of unparalleled pressure, and what it produced was a human mind and a social fabric refined to its sharpest point. Every person alive today is descended from those few thousand survivors who endured that terrible winter. Their resilience, their ingenuity, and their profound social connection became our genetic and cultural inheritance. So when the climate finally began to shift again and the ice slowly loosened its grip, these were not the same people who had entered the freeze. They were a species hardened, unified, and equipped with the very tools they would need to finally step out of their African cradle and walk into the waiting world. The penultimate winter did not just test humanity, it distilled us. The world our ancestors inherited was about to be taken away. 115,000 years ago, the long, pleasant interglacial warmth that had followed the penultimate winter began to falter. A slow, inexorable cooling crept across the planet, marking the opening act of our most recent and defining ice age, the last glacial period. This was not a sudden plunge, but a gradual dimming of the global thermostat, a climatic shift measured in centuries and millennia. In the north, winter snows began to linger through the summer, accumulating year after year, compressing into dense layers of glacial ice. From their strongholds in Scandinavia and the Alps, the ice sheet stirred, beginning their slow, grinding march southward once more. Forests of pine and birch retreated before the advancing cold, replaced by a vast, open landscape of tundra and steppe, a land of little shelter and relentless wind. For the Neanderthals, masters of Europe through several glacial cycles, this early phase presented a familiar but escalating challenge. Their entire way of life was built around the rhythms of the megafauna, the mammoth and reindeer herds that were the Ice Age's walking larders. As the climate shifted, these herds altered their migration routes, and the plant communities that provided crucial seasonal forage changed. The Neanderthals' deep, generational knowledge of specific valleys and hunting grounds was suddenly being rewritten by the climate itself, forcing a new level of adaptability even for these supremely adapted people. Meanwhile, in Africa, a different drama was unfolding. Homo sapiens, having survived the genetic bottleneck of the previous glacial maximum, were beginning to flourish in a variety of environments. But this new cooling brought a familiar threat, a return of the aridity that had nearly wiped them out. Lakes shrank, grasslands turned to dust, and the continent's interior became a barrier once again. This early phase of the last glacial period acted as a powerful disperser, pushing small bands of modern humans to the edges, to the coasts where marine resources offered stability, and along the Nile Valley, a green artery through an increasingly brown land. It was the opening scene of a 100,000-year drama, a slow-motion environmental pressure that would, step by step, set the two human species on a collision course across a shrinking and demanding world. The cold reached its zenith. Around 26,000 years ago, the world entered the deepest freeze of the last 100,000 years, a climatic event so definitive it is known simply as the last glacial maximum. For 7,000 years, the planet held its frozen breath. In North America, the Laurentide ice sheet was a continental empire of white, spanning from the Atlantic to the Rockies and burying what is now New York City and Chicago under over a mile of solid ice. Across the Atlantic, the Fennoscandian sheet smothered Scandinavia, Britain, and much of northern Europe. So much of the world's water was locked in these icy vaults that global sea levels plummeted by over 400 feet. Coastlines were not just altered, they were unrecognizable. A vast plain, now called Doggerland, connected Britain to mainland Europe. The islands of Indonesia were fused into a single landmass known as Sunda. Most consequentially, the Bering Land Bridge emerged as a wide, 1,000-mile corridor of grassy steppe, linking Siberia to Alaska. But this exposed land was no paradise. With so much moisture trapped in ice, the global climate became intensely dry. Deserts expanded, and even the ice-free zones between the glaciers were often arid, wind-swept tundras, where dust storms were common and survival was a relentless calculation of calories. This was the world at its most compressed, a planet where hospitable land had shrunk dramatically, squeezing all life into fragmented refugia. For every human society on Earth, this was the ultimate bottleneck. In Europe, Neanderthal populations, already stressed, were pushed into isolated southern peninsulas like Iberia and Italy, clinging to survival in shrinking pockets of relative warmth. In East Asia, groups hunkered down in protected river valleys, and in Africa, our Homo sapiens ancestors were once again confined, likely to a few key regions with reliable water and food, like the Cape of Good Hope and parts of the eastern coast. This extreme compression was not just a geographical squeeze, it was a forge for innovation. When resources are scarce and margins are thin, technology is not a luxury, it is the difference between life and death. We see this in the archaeological record from this period. Stone tools become smaller, more refined, and more specialized, like the delicate bladelets of the Gravettian culture in Europe, which could be hafted onto spears or carved into needles for sewing tightly fitted clothing from animal hides. The invention of the eyed needle was a revolution in thermal efficiency, allowing for the creation of layered, waterproof garments essential for venturing out into the glacial cold. This was also a time when the use of projectile technology, like spear throwers or atlatls, likely became more widespread, enabling hunters to take down large, dangerous game from a safer distance, a crucial advantage when every injury could be fatal. Social networks, too, would have been strained and strengthened over vast distances, as groups separated by harsh terrain might have maintained connections through trade of rare materials like good flint or decorative shells, creating thin threads of cultural continuity across a frozen world. The last glacial maximum was the Great Filter, a 7,000-year winter that tested every adaptation humanity had painstakingly built. It pushed our ancestors to the absolute limit of their ingenuity, forcing them to refine their tools, their social bonds, and their very understanding of a world that had become overwhelmingly hostile. The societies that emerged from this deep freeze were not the same as those that entered it. They were leaner, smarter, and equipped with a hardened resilience, standing on the threshold of a great change that was already stirring in the melting ice. While ice gripped the northern continents, a different kind of frontier was emerging in the southern hemisphere. Sea levels 400 feet lower than today performed a geographical magic trick, stitching together land masses that are now separated by ocean. Australia, New Guinea, and Tasmania fused into a single colossal continent that scientists call Sahul. This was not a gentle merging of coastlines, but the dramatic exposure of a vast, dry continental shelf, creating a landscape of sprawling savannas, inland lakes, and mountain ranges that no human eyes had ever seen. To reach this untouched world, however, required a voyage of breathtaking audacity. Even at the glacial maximum, Sahul remained isolated by deep ocean trenches, meaning the first people could not simply walk there. They had to cross the sea. The journey from the nearest landmass, Sunda in Southeast Asia, involved navigating at least 60 miles of open water, a voyage visible from start to finish on a clear day but fraught with peril on the unpredictable Pleistocene seas. This was not a chance drift on a log. Reaching Sahul required deliberate, planned maritime exploration. We are talking about groups constructing watercraft sturdy enough to carry families, tools, and possibly even live animals, then setting out across a horizon they knew held land, guided by the plumes of distant volcanoes or the flight patterns of birds. This successful crossing, occurring at least 65,000 years ago, represents the earliest evidence of sophisticated seafaring in human history. It speaks to a profound package of skills, an ability to plan for a future beyond the visible shore, to understand seasonal winds and currents, and to maintain social cohesion during a terrifying, days-long journey into the absolute unknown. Once they landed, these pioneers entered a continent of bizarre and formidable megafauna, like the 2-ton wombat relative Diprotodon and the giant lizard Megalania. Their survival in this new world, without any prior knowledge of its ecosystems, is a testament to the ultimate adaptability forged by the ice ages. The peopling of Sahul stands as a monument to human courage and ingenuity, proving that even at the height of a global winter, our ancestors were not merely surviving, they were navigating the open ocean to conquer new worlds. The immense ice sheets held the world in a frozen lock, but they also built a bridge. During the long millennia of the last glacial maximum, so much ocean water was trapped as ice that the floor of the Bering Sea rose from the depths, exposing a continent-sized span of land connecting Asia to North America. This was Beringia, a vast, unglaciated grassland the size of modern-day Texas, a lost world that served as the stage for humanity's final great terrestrial migration. It was not the icy wasteland you might picture. Freed from the crushing weight of the glaciers to the east and south, and kept dry by the rain shadow of mountains, Beringia became a mammoth steppe, a cold but incredibly productive ecosystem. In summer, it bloomed with grasses, herbs, and flowers, supporting an astonishing array of megafauna. Woolly mammoths, steppe bison with horns spanning 6 feet, scimitar cats, and giant short-faced bears all thrived in this cold paradise. For the skilled hunter-gatherers living in Siberia, this rich, open landscape was not a barrier. It was an irresistible invitation, a slowly expanding frontier of game and opportunity as the sea level dropped. They did not see themselves as crossing a bridge to a new world. They were simply following the herds, season after season, generation after generation, into a land that had always been there. This gradual, incremental movement over centuries is the heart of the Beringian standstill theory, which suggests people may have lived and thrived on this land bridge for thousands of years, genetically and culturally distinct from their Asian ancestors, before the retreating ice finally opened a path south. That path, the ice-free corridor between the Laurentide and Cordilleran ice sheets, was long thought to be the sole gateway, but a compelling alternative theory has gained ground, the Kelp Highway. As the ice retreated, it left a shattered coastline rich with marine life. Some of the first pioneers may have never set foot on the Beringian plain at all, but instead traveled by boat, skirting the icy rim of the North Pacific from Asia, down along the coast of Alaska and British Columbia, living off the abundant resources of kelp forests, shellfish, seals, and migrating fish. This coastal route, potentially open earlier than the inland corridor, would have provided a linear, resource-rich highway into the heart of the continents. Whether by land or by sea, or more likely a combination of both, these first Americans carried with them the cumulative knowledge of surviving 30 ice ages. They walked into a world empty of humans but teeming with giant animals that had never learned to fear them. Their arrival, sometime between 20,000 and 15,000 years ago, set in motion a demographic and ecological revolution that would forever alter the history of two continents, a story written not in stone but in the silent, melting wake of the ice. The world of the last glacial maximum was not merely endured, it was mastered. In the frozen heart of southwestern Europe, a society of hunters and artists reached a dazzling peak of Paleolithic achievement. These were the people of the Solutrean culture, thriving between 22,000 and 17,000 years ago in what is now France and Spain. Their existence was a defiant testament to human ingenuity, a brilliant flame burning against the backdrop of a mile-thick ice sheet just to the north. To survive in that world required more than basic tools. It demanded artistry, precision, and a deep spiritual connection to the landscape. The Solutreans are renowned for their stone technology, a leap in craftsmanship that seems almost miraculous. They perfected a method called pressure flaking, using a pointed tool of bone or antler to press, not strike, tiny, controlled flakes from a pre-shaped stone core. The result was not a crude hand axe, but a thing of breathtaking beauty and lethality, the laurel leaf point. These blades were often longer than a human hand, wafer-thin, symmetrical, and so finely worked they appear translucent when held to the light. Creating one was an act of immense patience and skill, a process that could take hours and risked shattering the piece at any moment. This was not mere tool-making, it was a high-stakes art form, producing the sharpest, most effective projectile points the world had ever seen, capable of bringing down the massive horses and reindeer that roamed the glacial steppe. But their genius was not confined to the hunt. In the deep, silent caves of the Dordogne Valley, like the now iconic Lascaux, the Solutreans and their successors painted. They mixed pigments from ochre and charcoal, used hollow bones as spray painters, and by the flickering light of animal fat lamps, they brought the walls to life. Herds of charging aurochs, elegant stags, and mysterious abstract symbols cascade across the rock. This art was far more than decoration. It was a profound interface with their world, a way to assert control over the unpredictable forces of nature, to ensure the return of the herds, or to document the turning of the seasons in a place where sunlight never reached. To crawl into those pitch-black chambers and create such vibrant, moving scenes speaks to a complex inner world, a rich mythology, and a shared identity that bound the community together against the external cold. The Solutreans were the ultimate Ice Age specialists. They sewed tailored clothing with eyed needles, built substantial shelters from mammoth bones and hides, and organized sophisticated communal hunts. They did not just scrape by in the freeze, they built a vibrant, symbolic culture within it, a pinnacle of human adaptation that proves even the deepest winter could not extinguish the drive to create, to understand, and to thrive. The deep freeze could not last forever. As the last glacial maximum began to wane, the great ice sheets started their slow, groaning retreat, and a new society rose to dominate the thawing landscapes of Europe. This was the world of the Magdalenian culture, the last great flourish of the Ice Age hunters. Their existence was built upon a single, majestic creature, the reindeer. These vast herds were the moving heart of the Magdalenian world, a predictable, renewable resource that provided everything: meat for food, sinew for thread, antlers for tools, and hides for clothing and shelter. The yearly migrations of the reindeer dictated the rhythm of life, a calendar written in hoofprints across the tundra. To follow them, the Magdalenians mastered a new kind of existence, one of elegant mobility. Their art reflects this perfectly. While their Solutrean predecessors painted deep within caves, the Magdalenians created a portable world of beauty. They engraved intricate scenes of running horses and charging bison onto slabs of stone and bone. They carved delicate, three-dimensional sculptures of animals from reindeer antler, like the famous leaping horse found at the site of La Madeleine in France. They even invented the spear thrower or atlatl, and then turned this hunting tool into a canvas, adorning it with carved ibex or mammoths. This was art meant to be carried, touched, and used, a constant companion in a life on the move. This mobility, however, did not mean isolation. In fact, the challenging conditions of the late glacial world forced an incredible level of social connection. The Magdalenians developed extensive trade networks that spanned hundreds of miles across a still frozen continent. Seashells from the Atlantic coast have been found deep in inland German caves. Distinctive flint from specific quarries in Poland traveled west into France. Amber from the Baltic appears in southern sites. This exchange was not merely economic, it was social and symbolic. It created alliances, facilitated the sharing of knowledge and technology, and wove a web of relationships that provided a safety net in an unpredictable environment. If one local herd failed, connections to distant groups could mean survival. The evidence suggests they gathered in large, seasonal aggregations, perhaps at key river crossings where reindeer herds were funneled, coming together from across the region. These would have been times of feasting, storytelling, marriage arrangements, and the exchange of those exquisite portable artworks, solidifying a shared cultural identity. The Magdalenians show us that the Ice Age did not produce simple, scrabbling bands, but sophisticated, interconnected societies. The very harshness of their world demanded cooperation on a grand scale, fostering the trade, art, and complex social structures we often associate only with later agricultural civilizations. They were not waiting for the ice to end. They were building a vibrant, resilient culture within its very grip. A final, brilliant testament to human adaptability before the world changed forever. The world seemed to be on a steady path out of the winter. For thousands of years, the great ice sheets had been retreating, forests were reclaiming the tundra, and human societies like the Magdalenians were thriving in the new abundance. Then, with shocking speed, the calendar was ripped up. Roughly 12,900 years ago, just as the planet was breathing a sigh of relief, a climatic trapdoor swung open. In a geological instant, perhaps within a single human lifetime, global temperatures plummeted back to near glacial conditions. This was the Younger Dryas, a brutal 1,200-year cold snap that felt like a cruel joke from the climate itself. The evidence for this sudden freeze is written in ice cores from Greenland, where layers of ancient snowfall are preserved like pages in a book. The chemistry of that ice tells a clear story, a dramatic plunge in temperature markers right at this moment. Pollen records from lake beds across Europe and North America show a sudden, violent reversal. Tree pollen vanishes, replaced by the pollen of cold-tolerant, tundra-dwelling plants like the Dryas flower, which gives this period its name. It was as if the Ice Age had returned with a vengeance, slamming the door on the emerging spring. But what could cause such a rapid, catastrophic reversal in a warming trend? One of the most compelling and debated theories points to the skies. A growing body of evidence suggests a comet or asteroid may have fragmented and exploded in the atmosphere over North America. The clues are tantalizing and widespread. At archaeological sites dating to this exact time, scientists find a thin, dark layer of sediment rich in unusual materials, a platinum spike, microscopic diamonds called nanodiamonds, and tiny magnetic spheres that form only under immense, sudden heat and pressure, the kind generated by an extraterrestrial impact. This black matte layer sits directly atop the remains of the Clovis culture in North America and the bones of the megafauna they hunted. The proposed impact, even if it was an airburst and not a ground strike, would have been an unimaginable cataclysm. It could have triggered continent-wide wildfires, a soot-filled nuclear winter that blocked the sun, and a rapid climate shift that pushed a fragile, warming world back into the deep freeze. The effects were apocalyptic. In North America, the sophisticated Clovis culture, known for their distinctive fluted spear points used to hunt mammoths and mastodons, vanished almost overnight from the archaeological record. Their signature tools are never found above that black mat layer. The megafauna they relied upon, from the giant ground sloth to the American camel, suffered catastrophic population collapses and, for many species, total extinction. This was not a slow decline from overhunting, but a sudden, synchronous die-off that aligns perfectly with the climate crash. Across the Atlantic, the story was similar. In Europe, the prosperous reindeer hunting societies of the late Paleolithic were thrown into chaos as the herds they depended on migrated or died out. Perhaps most significantly, in the Fertile Crescent of the Middle East, where some human groups had begun the first tentative experiments with cultivating wild grains, this cold snap was a disaster. Just as people were starting to settle and nurture plants, a 1,000-year winter descended. The wild stands of wheat and barley they were beginning to manage likely failed, forcing these nascent farmers to abandon their settlements and revert to a mobile, hunting and gathering lifestyle to survive. The Younger Dryas was a global reset button, a violent interruption that demonstrated humanity's profound vulnerability to sudden climate change. It wiped out advanced cultures, reshaped entire continents' ecologies, and delayed the very birth of agriculture. Yet, in its devastating wake, it also created a new kind of pressure, a final, harsh lesson from the ice that would ultimately force our ancestors to make a choice that would change everything. The Fertile Crescent was a trap. For generations, small bands of hunter-gatherers had thrived there, moving with the seasons between wild stands of wheat and barley in the hills and the gazelle herds on the plain. They were not farmers, but they were sophisticated managers of their landscape, perhaps even encouraging their favorite grasses by weeding out competitors or scattering seeds. They were on a gentle, evolutionary path toward a more settled life. Then the Younger Dryas winter descended, and that path vanished overnight. The cold and aridity shattered the old rhythms. The gazelle herds became unpredictable. Most devastatingly, the wild grain stands, those lush natural pantries, retreated to a few desperate refuges, clinging to life in sheltered valleys and near reliable water sources. The vast, open buffet was gone, replaced by a few scattered, shrinking tables. The people faced a stark choice: disperse and follow the vanishing game into an increasingly harsh landscape, or stay put and protect what little remained. Many groups chose to stay. They clustered around these last oases of edible grass, these tiny islands of food security in a sea of cold and drought. But staying meant fighting for every calorie. They could no longer afford to simply harvest and move on. They had to invest. They began to clear competing plants more aggressively. They carried water from springs to the struggling stands. They guarded the precious grasses from birds and rodents. Most importantly, they began to consciously select which plants to cultivate. In the wild, grains have a natural adaptation called a brittle rachis, the stem that holds the seed to the plant. When mature, it shatters easily, scattering seeds to the wind to ensure the next generation. For a mobile forager, this is fine. You collect what you can. For a settled group trying to maximize a harvest from a small, precious plot, this trait is a disaster. Imagine trying to gather rice if the grains exploded off the stalk at the slightest touch. The early cultivators, without any understanding of genetics, began a process of unconscious selection. They naturally tended to harvest the plants whose seeds clung on a little longer, the ones with a tougher rachis that didn't shatter when brushed. They brought these seeds back to their settlement and sowed them the next season. Over generations, this relentless, crisis-driven selection changed the plants themselves. The tough rachis mutants, which would have been a dead end in the wild, became the dominant crop. The wheat and barley became dependent on humans to sow them, and humans became dependent on the grains for survival. This was not a discovery, it was a desperate bargain struck under climatic duress. The Neolithic Revolution, the birth of farming, was not a brilliant invention born in a time of plenty. It was a survival strategy forced upon people by a 1,200-year winter. The granaries, the permanent villages, the social hierarchies, and eventually the first cities all grew from the roots of those climate-stressed grasses. Our entire civilized world, with all its wonders and complexities, is in many ways the long-term consequence of a desperate adaptation to the 20th Great Ice Age. The bargain with the grain had been struck, but the climate was not done testing its new partners. Just as the first farming villages were taking root across the Fertile Crescent, a new kind of winter arrived, one born not from the sky, but from the melting heart of the continent itself. Roughly 8,200 years ago, a climatic shockwave rippled across the northern hemisphere, an event so precise in the geological record it is known simply as the 8.2 kiloyear event. This was not a millennia-long glaciation, but a sharp, brutal cold snap that lasted for over a century. Its cause was a spectacular release of pent-up pressure from the retreating ice. In North America, the colossal Laurentide ice sheet had been melting for thousands of years, its meltwater forming a vast inland sea dammed by ice known as Lake Agassiz. Then the dam broke. Whether it was a gradual overtopping or a catastrophic collapse, an immense volume of cold, fresh water, equivalent to several times all the water in the Great Lakes today, roared into the North Atlantic Ocean in a geological instant. This freshwater flood was a poison pill for the planet's climate engine. It diluted the salty, dense waters of the North Atlantic that normally sink and drive the great oceanic conveyor belt, the Gulf Stream's northward flow of warm water that keeps Europe temperate. The conveyor slowed, perhaps even stalled. The result was a sudden, dramatic cooling, a return to near glacial conditions that lasted for generations. For the early farming communities scattered from Anatolia to the Levant, this was a disaster of a scale they had never known. Their entire existence was now tethered to the annual cycle of their carefully bred crops. A single bad season was a hardship, but a century of cooler, drier, and more unpredictable weather was an existential threat. The archaeological record from this period tells a story of stress and upheaval. At the famous site of Çatalhöyük in Turkey, one of the world's earliest large settlements, evidence shows a shift. The elaborate wall paintings and ritual practices that characterized its earlier layers become less frequent, hinting at a society turning inward, focusing more on survival than symbolism. Across the region, many smaller villages were simply abandoned, their inhabitants likely dispersing back into a more mobile lifestyle or migrating in search of stable land. This forced movement, however, had a profound unintended consequence. As people fled the failing fields, they carried their hard-won agricultural knowledge with them, spreading seeds, techniques, and animal husbandry practices into new territories like the Balkans and across the Mediterranean into Europe. The 8.2 kiloyear event acted as a violent accelerant for the Neolithic diaspora, pushing the farming revolution outward at a pace that peaceful expansion might never have achieved. Furthermore, surviving such a prolonged crisis demanded new forms of social organization. Managing scarce water, storing grain across multiple bad years, and coordinating labor for new irrigation projects required stronger leadership and more defined social roles. The need to plan for collective survival in the face of a capricious climate may have been the crucible that forged the first entrenched social hierarchies, transforming informal village elders into the chiefs and priests who could command labor and redistribute resources. This century-long winter, a direct aftershock of the melting ice sheets, proved that the agricultural experiment was fragile. It showed that settling down did not mean escaping nature's whims, but rather tying human destiny even more tightly to them. The response to this fragility, the migrations, the new technologies, and the stronger social structures, would become the blueprint for the next great challenge, one that would see ice itself become a tool for empire. The climate's next strike came from a different direction. 5,900 years ago, as the great northern ice sheets were distant memories, a sudden chill descended on the Alps and the Mediterranean world. This event is known as the Piora Oscillation, a 200-year period of colder temperatures and dramatically increased rainfall. Its epicenter was the high Alps, where glaciers that had been retreating for millennia suddenly lurched forward again, grinding down valleys they had long abandoned. The evidence is locked in the mud at the bottom of alpine lakes, where pollen records show a sharp decline in warm-loving trees and a surge in cold-tolerant grasses and shrubs. This was not a global ice age return, but a powerful, regional climate shock that rippled across the emerging civilizations of Europe and the Near East. For the farming communities that now dotted the landscape, this oscillation presented a cruel paradox. The increased rainfall was a blessing for some, filling rivers and watering crops. But the accompanying cold shortened growing seasons, and in the highlands, the advancing glaciers and relentless storms made life untenable. Entire villages in the alpine foothills were abandoned, their inhabitants forced to flee to lower, warmer valleys. This compression of populations into more confined spaces inevitably increased competition for the best land. The archaeological record from this period shows a marked increase in fortified settlements and evidence of violent conflict. The idyllic, spread-out world of early European farmers was collapsing under climatic pressure, giving way to a new era of defensive walls, organized warfare, and social stratification. This upheaval provides a compelling backdrop for one of prehistory's greatest mysteries, the sudden and rapid spread of the Indo-European languages. Linguists and archaeologists have long debated how languages ancestral to modern English, Greek, Hindi, and Russian came to dominate from India to Ireland. The Piora Oscillation offers a potent catalyst. Imagine nomadic pastoralist groups from the steppes north of the Black Sea, skilled horse riders accustomed to harsh, variable climates. As the oscillation made farming more difficult in Europe, these mobile groups, less tied to fixed fields, may have found their moment. They could have moved into the disrupted regions, their mobility and martial culture giving them an advantage over stressed, sedentary farmers. Their language and customs could have spread not solely through conquest, but through assimilation, trade, and the sheer prestige of a successful adaptation to a changing world. While the debate is far from settled, the Piora Oscillation stands as a stark reminder that even a relatively short climate event, just 2 centuries of cold and wet, could fracture societies, redraw cultural maps, and set in motion linguistic legacies that would echo for thousands of years. The Chalcolithic period was meant to be an age of copper and growing prosperity, but for many, it became an age of rain, frost, and fortification. The world's fragile new order was about to face its ultimate stress test. 4,200 years ago, a climatic disaster of unprecedented scale gripped the planet. A drought so profound and prolonged it is etched into the geological record as the 4.2 kiloyear event. This was not a local famine or a few bad harvests, but a centuries-long aridification that desiccated the very heartlands of early civilization. From the Nile to the Indus, rainfall patterns failed, rivers shrank, and the agricultural foundations of the first great empires turned to dust. Modern climate proxies, from ancient lake beds to stalagmites in caves, all tell the same story: a sharp, sustained drop in monsoon rains and a dramatic shift in global atmospheric circulation that lasted for over 300 years. This was the first truly global climate crisis, and its victims were the Bronze Age superpowers that had believed themselves masters of their world. In Egypt, the crisis struck at the divine authority of the pharaohs. The Old Kingdom, the age of pyramid builders, was a state utterly dependent on the predictable annual flood of the Nile. The inundation brought water and rich silt, the lifeblood of the fields. When the 4.2 kiloyear event disrupted the monsoon systems that fed the Nile sources in the Ethiopian highlands, the floods failed. The river became a trickle in its bed. Years of low floods turned into decades and then into centuries. The result was catastrophic famine. Tomb inscriptions from this period speak of despair, of people eating their children and resorting to cannibalism. The central government in Memphis, whose power was based on its ability to collect and redistribute grain, found its granaries empty. Provincial governors, unable to rely on the crown, began to assert their own independence, hoarding local resources. The social contract between the god-king and his people shattered. The majestic pyramid-building era ended not with a bang, but with a whimper of starvation and civil war, fragmenting Egypt into competing petty states for over a century. The climate did not just challenge the old kingdom, it revealed the fundamental vulnerability of a civilization built on a single, fragile river. 1,000 miles to the east, the Akkadian Empire in Mesopotamia faced a parallel catastrophe. Founded by Sargon the Great, Akkad was history's first multi-ethnic empire, stretching from the Persian Gulf to the Mediterranean. Its wealth was built on grain from the fertile alluvial plains of the Tigris and Euphrates, watered by an extensive network of irrigation canals. The 4.2 kiloyear event brought not just drought, but also punishing winds that filled those canals with sand and dust. Agricultural collapse was swift and total. At the imperial capital of Akkad, archaeologists find a layer of sterile wind-blown sediment directly atop the ruins of the glorious city, a literal dust bowl that buried its greatness. The epic poem The Curse of Akkad, written soon after the collapse, describes the disaster in haunting terms, saying the great fields produced no grain, the irrigated orchards produced no syrup, and the clouds gave no rain. Facing starvation, the empire's subject cities revolted. The Gutian tribes from the northern mountains, themselves desperate from the drought, swept down into the plains. The empire disintegrated into chaos. Here, the climate crisis acted as a brutal amplifier of social and political tensions, proving that even the most sophisticated administrative systems could not hold when the rains refused to fall and the dust storms began to blow. Meanwhile, in the Indus Valley, a different kind of civilization met a quieter, but no less fatal, end. The Harappan cities like Mohenjo-Daro and Harappa were marvels of urban planning with standardized bricks, elaborate drainage, and a seemingly egalitarian society. They too relied on monsoon-fed rivers, including the mighty but unpredictable Gaga-Hakra river system. As the monsoons weakened and shifted southward during the 4.2 kiloyear event, these rivers began to dry up or change course. The slow death of the Indus Valley civilization was not marked by invasion or obvious violence, but by a gradual, relentless abandonment. Archaeologists see the story in the changing settlement patterns. People began leaving the large, water-intensive cities in the north. They moved eastward and southward toward regions with more reliable rainfall, founding smaller, simpler villages. The meticulous urban order broke down, writing disappeared, and the cultural unity of the civilization dissolved into regional cultures. This was not a sudden collapse, but a climate-driven migration, a long, strategic retreat from a landscape that could no longer support a complex, centralized way of life. The great cities were not sacked, they were simply left to the encroaching sand, monuments to a climate that had shifted beneath their feet. 3 cradles of civilization, 3 different paths to ruin. The 4.2 kiloyear event stands as a sobering lesson from the deep past, a demonstration that environmental change can be the ultimate kingmaker. It toppled god-kings, unraveled empires, and scattered urban populations, not with armies or plagues, but with the simple, relentless absence of rain. This was the 23rd Great Winter, a drought of the ages that reset the Bronze Age world and asked a haunting question of every society that would follow. How do you build something lasting when the very sky can turn against you? The dust had barely settled from the 4.2 kiloyear event when the climate pendulum swung again. Starting around 1500 BCE, a subtle but relentless chill began to seep back into the northern hemisphere. This was not a sudden plunge, but a gradual cooling trend that would last for 1,000 years, a climatic backdrop now called the Bronze Age Cold Epoch. Average temperatures dipped, glaciers in the Alps and Scandinavia advanced once more, and growing seasons shortened across Europe and the Near East. The effects were not uniform, but they were devastatingly consistent in one outcome: drought. As the global climate system shifted, rainfall patterns that had sustained empires for centuries began to fail. The Eastern Mediterranean, a crossroads of trade and culture, entered a prolonged period of aridity. Rivers shrank, harvests withered in the field, and the specter of famine returned with a vengeance. For the palatial, centralized economies of the late Bronze Age, this environmental stress was a slow-burning fuse. The Hittite Empire in Anatolia, utterly dependent on grain from its fertile plains, faced chronic food shortages. Clay tablets from their capital plead for emergency grain shipments from Egypt, revealing a network of kingdoms all straining under the same climatic pressure. When the famine deepened, social order began to fray. People abandoned starving villages, becoming refugees and bandits. This widespread desperation created a tinderbox, and the spark came from the sea. From the murky depths of historical records emerged the so-called Sea Peoples, a confederation of maritime raiders who erupted into the eastern Mediterranean around 1200 BC. Egyptian temple reliefs at Medinet Habu show them in fierce naval battles, their ships and distinctive feathered helmets locked in combat with Pharaoh Ramses III's forces. For decades, these invaders were seen as a mysterious external force that toppled empires, but modern archaeology suggests a more complex, climate-driven story. The Sea Peoples were likely not a single ethnic group, but a cascading wave of displaced populations from the collapsing edges of the Bronze Age world. They were a mix of uprooted farmers from drought-stricken Anatolia, displaced pirates from the Aegean Islands, and desperate coastal communities from regions we now call Sardinia and Sicily. The prolonged cold and drought had shattered their homelands, leaving them no choice but to take to the sea in search of new land and survival. They moved in a destructive migration, not as a coordinated army, but as a storm of hunger and desperation. They sacked the great trading city of Ugarit on the Syrian coast, whose last frantic clay tablet message found in the kiln was a plea for help that never came. They contributed to the fall of the Hittite Empire and challenged Egypt itself. This was not an invasion in the traditional sense. It was a climate-driven diaspora of unprecedented violence, a human tsunami crashing against the weakened walls of palace civilization. The aftermath was a profound silence. In Greece, the vibrant Mycenaean culture, with its fortified palaces like Mycenae and Pylos, collapsed entirely. The great halls were burned and abandoned. The intricate linear B script used for palace inventories was forgotten. Long-distance trade evaporated. The population plummeted. What followed was a 300-year period so devoid of writing, monumental architecture, and complex art that historians call it the Greek Dark Ages. It was a societal reset of staggering scale. People retreated into small, isolated villages, their horizons shrinking to the next valley. The sophisticated skills of fresco painting, metalworking in bronze, and bureaucratic administration were largely lost. Life reverted to a simpler, harder, more local existence. This was the bleak, quiet consequence of the Bronze Age cold epoch, a winter that erased not just harvests but memory itself. Yet within this enforced simplicity, new seeds were planted. The collapse of the rigid, hierarchical palace systems broke the power of divine kings. In the small, struggling communities of the Dark Ages, new forms of social organization had to be forged. Leadership became more consultative out of necessity. The shared struggle fostered a different kind of identity, one based not on serving a remote wanax or king, but on the cohesion of the community itself, the polis. The old Mycenaean Greek dialect splintered into regional variants as communities grew isolated, laying the groundwork for the diverse city-states to come. And crucially, with the loss of abundant bronze due to shattered trade networks, people turned to a more widely available metal, iron. the technology for working iron, which requires higher temperatures than bronze, had been known but was not prioritized. Now, out of sheer necessity, it was refined and democratized. Iron ore was common, and tools and weapons made from it, while initially inferior, became accessible to many, not just a palatial elite. This technological shift would one day level the battlefield both literally and socially. The Greek Dark Ages, then, were not merely a barren interlude. They were a necessary winter, a fallow period where the old, brittle structures of the Bronze Age were cleared away. The cold epoch that brought drought, famine, and the sea peoples also created the empty space and the raw conditions for a revolutionary new experiment in human society to take root. From the dark, frozen soil of collapse, the seeds of classical Greece would eventually and improbably sprout. Even the sun itself seemed to grow weary. As the Greek Dark Ages persisted, a profound astronomical shift was underway, a quiet dimming of our star now known as the Homeric minimum. For several centuries, starting around 900 BC, solar activity dropped significantly, marked by a near absence of sunspots recorded in ice core and tree ring data. Fewer sunspots meant a slightly less active sun, and on Earth, that translated to a subtle but impactful global cooling. The world did not plunge into a deep freeze, but it entered a period of cooler, wetter, and more unstable weather, a climatic sigh that settled heavily over the emerging Mediterranean world. This was the 25th Great Winter, a solar-powered chill that colored an entire age. We can almost feel this climate in the very literature that defines the era. Homer's epics, the Iliad and the Odyssey, composed toward the end of this minimum, are drenched in a specific, gloomy atmosphere. This is not the sun-drenched Greece of tourist brochures. Homer's world is one of iron skies, relentless rain, and storm-racked seas. The Odyssey is essentially a 10-year battle against hostile weather, with Poseidon stirring up one vengeful tempest after another. Descriptions of wine-dark seas and misty mountains evoke a landscape frequently veiled in cloud and spray. While poetic license is at play, the consistency of this dismal weather suggests a cultural memory forged during a time when leaden skies and cold rains were simply the norm of life. This had concrete, demanding consequences on the ground. Cooler, wetter summers meant shorter growing seasons and frequent harvest failures. Grain, the staple of life, would have been harder to reliably produce, especially on the marginal hillside farms that many communities relied upon. This persistent agricultural stress acted as a constant brake on population growth and a relentless driver for migration and conflict. Settlement patterns across Greece began to shift in response. People increasingly sought out land with better drainage and more reliable microclimates, often moving down from exposed highlands to more sheltered coastal plains. But the coast brought its own dangers, as rising sea levels from melting glaciers elsewhere could have threatened low-lying areas, a double-edged sword of climatic change. This environmental pressure cooker fundamentally shaped the geopolitical landscape. Scarce, reliable farmland became the most precious commodity, the ultimate source of wealth and power. Competition for these fertile valleys fueled the rise of the independent, fortified city-state, the polis. Each community had to fiercely guard its arable land, its kora, from jealous neighbors. The constant threat of poor harvests made storage and redistribution of grain a central political function, encouraging stronger, more organized leadership. It also fueled the great wave of Greek colonization that began in the 8th century BCE, as city-states sent out their surplus sons, or more likely their hungry ones, to establish new farming settlements from the Black Sea to southern Italy. They were not merely seeking trade, they were exporting their climate-driven food insecurity. The Homeric minimum, therefore, was more than a literary backdrop. It was an environmental architect that helped mold the very character of archaic Greece. It fostered the intense localism, the martial competitiveness, and the desperate ingenuity that would define the classical era. The gloomy weather of the epics was not just a setting for heroic deeds, it was the very reason heroism, in the form of survival and expansion, became a collective necessity. The sun's long dimming finally lifted, but the chill it left behind lingered like a ghost in the soil. From roughly 900 to 300 BC, a persistent cold phase gripped northern Europe, a climatic backdrop now called the Iron Age Cold Period. This was not a dramatic Ice Age return, but a stubborn, centuries-long dip in temperatures that shortened growing seasons and brought wetter, harsher conditions to lands already on the agricultural edge. For the Celtic and Germanic tribes living in the forests and plains north of the Alps, this environmental squeeze became the engine of history. Their societies were built on farming and herding, and when the climate turned against them, they faced a brutal equation. Poor harvests and failing pastures meant hunger, and hunger meant movement. Driven by necessity, these tribal confederations began a slow, powerful drift southward, pressing against the natural barrier of the Alps and the Danube River. This was not a coordinated invasion, but a human tide, a relentless search for warmer land and reliable food. That tide crashed directly into the rising power of the Mediterranean world. The Roman Republic, still consolidating its control over Italy, suddenly found its northern frontier alive with a new kind of threat. In the 4th century BC, a Celtic war band swept over the Alps, defeated a Roman army at the Battle of the Allia, and then, in a moment of profound humiliation, sacked Rome itself. The city was looted and burned, a traumatic event that seared itself into Roman memory and taught them a harsh lesson about the volatile peoples beyond the mountains. This Celtic incursion was not an isolated raid. It was a symptom of the northern chill, a direct result of climatic pressure funneling desperate, martial populations toward the Mediterranean's warmth and wealth. The cold period did more than push people, it reshaped how they lived in the lands they left behind. In Scandinavia and the British Isles, where the cooling was especially pronounced, communities had to adapt or perish. The types of crops they could grow shifted. Hardier grains like barley and rye, which could tolerate shorter, cooler summers, became more crucial than temperamental wheat. Reliance on livestock, particularly cattle and pigs that could forage in forests, increased. Settlement patterns changed too. People often abandoned exposed, high-altitude farms for more sheltered valleys and coastal areas with slightly milder microclimates. They invested in better food storage, like underground pits lined with stone, to survive the long, uncertain winters. This constant negotiation with a demanding climate forged a resilient, adaptable, and fiercely independent culture. It honed the skills that would make the Celtic and Germanic tribes such formidable opponents for Rome for centuries to come. Their art, intricate and swirling, seems to capture the very motion of wind and water, a reflection of a life lived in deep dialogue with a volatile natural world. So when Julius Caesar marched into Gaul in the 1st century BC, he was not just confronting a foreign enemy, he was encountering the end product of a 600-year winter. The fierce resistance he met, the decentralized tribes, the deep knowledge of forest and bog, all of it was forged in the crucible of the Iron Age Cold Period. Rome's northern frontier problem, which would eventually consume so much of its military energy and lead to its dramatic overextension, was at its origin a climate problem. The chill that settled over northern Europe quietly assembled the very forces that would one day help bring the empire to its knees. Rome's golden age was built on a specific kind of weather. For centuries during the Roman climatic optimum, the Mediterranean world enjoyed unusually warm, stable, and predictable conditions. Vineyards flourished in southern Britain, and North Africa was the empire's breadbasket, its fields reliably drenched by consistent rains. This was not just good fortune, it was a foundational pillar. Reliable harvests filled the state granaries, funding the legions, feeding the sprawling cities, and greasing the wheels of commerce across a vast network. The empire's complex administrative machine, its Pax Romana, was fundamentally a fair weather system, Then, around 200 CE, the weather changed. The long summer began to fade, replaced by a cooler, more erratic and unstable climate pattern that would persist for centuries. This was not an ice age descending on the Forum, but a subtle, insidious shift. Growing seasons in the empire's northern provinces, like Gaul and Britain, shortened. Rainfall in the critical agricultural zones of North Africa and the Near East became less reliable, swinging between droughts and deluges. For an empire that had optimized itself for stability, this new variability was a poison in the veins. The first and most devastating blow was to the food supply. A series of poor harvests, no longer isolated incidents but a recurring pattern, triggered famines. Malnourished populations are fragile populations, and into this weakness swept the second blow, pandemic. The Antonine Plague in the 2nd century and the even more catastrophic plague of Cyprian that began around 250 CE ravaged the empire. These diseases likely found perfect breeding grounds in stressed, crowded, and underfed communities, their spread perhaps even influenced by changing climate patterns that altered the ranges of disease hosts. The death toll was staggering, with some estimates suggesting it wiped out a quarter of the empire's population at its height. This was a demographic catastrophe from which the Western Empire would never fully recover. It meant fewer farmers to work the land, fewer soldiers to fill the legions, and fewer taxpayers to fund the state. The economic machinery seized up. To pay for defense and the bloated imperial bureaucracy, emperors debased the currency, melting down silver coins and mixing in cheaper metals. This triggered rampant inflation, a crisis of confidence where prices soared and the very medium of exchange became untrustworthy. The government responded by demanding taxes in kind, in grain and goods, further straining the struggling agricultural system and pushing local landlords and small farmers into debt and dependency. This economic stress fractured the social contract. In the countryside, desperate farmers, the coloni, began binding themselves to powerful landowners for protection, foreshadowing the feudal system. In the cities, the decimated and impoverished middle classes, the curiales, who were responsible for local administration and tax collection, found their positions a ruinous burden rather than an honor. Many fled their posts, eroding the civic infrastructure that held the empire together. The Roman state responded to this polycrisis, this cascade of climate, disease, and economic failure, by becoming more authoritarian and militarized. Power concentrated in the hands of the emperor and the army, but the army itself was transforming. With the Italian heartland depopulated, Rome increasingly relied on recruiting barbarian mercenaries from beyond the frontier, the very peoples who were also feeling the pressure of the cooling climate to their north. The empire was, in effect, outsourcing its defense to the forces its own weakening had empowered. So when we speak of the fall of the Western Roman Empire, we are not telling a simple story of barbarian invasions. We are witnessing the slow-motion unraveling of a complex system. The end of the Roman climatic optimum removed the environmental certainty upon which that system was precariously balanced. It triggered a chain reaction, a synergy of disasters where crop failure led to pandemic, which led to economic collapse, which led to social fragmentation and military desperation. The Huns, the Goths, the Vandals, they were the final spark, but the tinder had been meticulously prepared by a changing climate. The 27th winter proved that even a superpower, at the height of its architectural and administrative genius, could be hollowed out from within by a shift in the wind and a failure of the rain. The empire's long winter was not yet over. In the spring of the year 536, a strange darkness fell across the world. Procopius, a historian in Constantinople, wrote that the sun gave forth its light without brightness like the moon all that year. From Europe to Asia, chroniclers in China and Ireland recorded the same eerie phenomenon, a dim, cold sun that cast no proper shadows, followed by unseasonable frosts and relentless crop failure. This was the beginning of the late antique Little Ice Age, a century-long climatic catastrophe sparked not by orbital shifts but by geological fury. Modern science has pinpointed the cause, a colossal volcanic eruption, likely in Iceland or North America, that blasted millions of tons of ash and sulfur aerosols into the stratosphere. These particles formed a global veil, reflecting sunlight back into space and plunging the planet into a volcanic winter. The year 536 was only the first blow. Tree rings from around the world show additional massive eruptions in 540 and 547, each one punching the climate back down just as it tried to recover. For over a decade, summers effectively vanished. Snow fell in August in China. Frosts withered grain in Italy in July. This was the ultimate failure of the seasons, a breakdown in the most fundamental rhythm of agricultural life. The consequences were immediate and apocalyptic. The years without summer triggered a famine of biblical scale. In Constantinople, the capital of the Eastern Roman Empire, people dropped dead in the streets from hunger. In Ireland, the chronicles simply state a failure of bread from the years 536 to 539, but starvation was only the opening act. Into this global population, weakened and huddling in the cold, came a second, even deadlier horseman. In 541, bubonic plague arrived at the Egyptian port of Pelusium, carried by rats on grain ships from the African interior. The disease found a perfect storm, a hemisphere of malnourished, densely packed victims. It exploded. This was the Justinian plague, the first recorded pandemic of bubonic plague in history. It swept through the Roman world like a scythe. At its peak in Constantinople, it was killing 10,000 people a day. Bodies were stacked in the open like cordwood, then stuffed into the towers of the city walls when graves ran out. The death toll is staggering, with modern estimates suggesting it killed perhaps a quarter to half of the entire population of the Mediterranean basin. The empire of Justinian, which had just reconquered Italy and North Africa in a stunning effort to restore Rome's glory, was hollowed out in a handful of years. The plague did not just kill people, it killed the future. There were not enough farmers to tend the fields, not enough soldiers to man the frontiers, and not enough taxpayers to fill the imperial coffers. Justinian's grand project of restoration collapsed under its own demographic weight, leaving the empire bankrupt, depopulated, and utterly vulnerable. This dual catastrophe of climate and disease did not merely weaken a single empire, it rewrote the map of Eurasia. In the steppes of Central Asia, the nomadic Avars, likely pushed by their own climatic hardships, began a long migration westward, eventually hammering against the weakened Roman frontiers. In Arabia, the prolonged drought and social chaos caused by the climate crisis created a fertile ground for a new, unifying message. The societal collapse and search for meaning in a seemingly broken world provided the context into which Islam was born in the early 7th century. The new faith then spread with astonishing speed, in part because the great powers that might have resisted it, the Eastern Roman and Sasanian Persian empires, had just spent a century bleeding each other white in wars while simultaneously being gutted by plague and famine. The late antique Little Ice Age was a true hinge of history. It shattered the classical world that had been limping along since Rome's fall and decisively cleared the stage for the medieval era. The dense, interconnected urban civilization of the Mediterranean never recovered its former scale or unity. Power fragmented, trade routes atrophied, and life became more localized, more rural, and more focused on mere survival. This 28th winter proved that nature could deliver a 1-2 punch of staggering force, using the very sky and the smallest of creatures to bring mighty civilizations to their knees and redirect the entire course of human destiny toward an unrecognizable future. The volcanic haze that blotted out the sun finally cleared, and the world began to warm once more. By the 9th century, a new climatic phase was dawning, one so distinct it would earn the name the medieval warm period. For roughly 4 centuries, from around 900 to 1300 CE, global temperatures rose, glaciers retreated, and the North Atlantic became a more navigable, less storm-tossed sea. This was not a uniform global heat wave, but a significant and sustained shift that opened a narrow window of opportunity in the far north. In Scandinavia, the growing seasons lengthened. Pastures that had been marginal became productive, supporting larger herds of cattle and sheep. Bountiful harvests of barley and rye could now be reliably grown in places that had previously struggled. This agricultural surplus fueled a population boom, and with more people came more pressure on the limited, fertile land of the Scandinavian fjords. The warming climate, however, offered a solution. It was not just the land that flourished, but the sea. The retreat of Arctic sea ice meant the legendary Viking longships, those shallow draft vessels of incredible speed and flexibility, could venture farther and with less risk. The North Atlantic was still a formidable challenge, but the storm tracks may have shifted slightly, and the ice that could crush a ship or block a passage was in retreat. The combination was explosive. Population pressure pushed and a warmer, more open ocean pulled. The result was the Viking Age, an era of exploration, trade, and settlement that stretched from the rivers of Russia to the shores of North America. They did not raid and explore in spite of the climate, they did so because of it. The warm period provided the essential environmental subsidy for their audacious journeys. They established thriving colonies in Iceland, where previously only a few Irish monks had dared to live. They pushed further west to a land they deceptively named Greenland to attract settlers. Around the year 985, Eric the Red led a fleet of settlers to the sheltered fjords of southwestern Greenland. For a time, it worked. The Norse established 2 main settlements, the eastern and western, with perhaps as many as 5,000 people at their peak. They built stone churches, kept dairy farms, and even exported walrus ivory and polar bear skins back to Europe. Their society was a direct transplant of Scandinavian medieval life, complete with a bishopric and tithes paid to the Norwegian crown. Greenland was not a marginal outpost, it was a functioning European colony, and its existence was entirely predicated on the favorable weather of the medieval warm period. But that window was already beginning to close. Starting in the early 13th century, the planet's climate engine began to shift again. The warm period was ending, and a long, erratic cooling trend was beginning, the dawn of what we now call the Little Ice Age. This was the 29th Great Winter, and its effects on the Norse in Greenland were slow, insidious, and ultimately fatal. The first and most critical blow was to their food supply. As temperatures dropped, the growing season in Greenland shortened dramatically. The hay needed to feed their livestock through the long winters became harder to produce. Pastures yielded less grass, and the fragile Arctic soil, overgrazed and stressed by the cold, began to degrade. Winters became longer and more severe, and the pack ice that had retreated began to advance again. This sea ice was a double curse. It made the vital sea routes to Iceland and Norway more treacherous and unpredictable, cutting off trade and communication for years at a time. Just as crucially, it brought the Inuit people, ancestors of the Thule culture, southward along the coast. The Inuit were supremely adapted to the cold, hunting seals and whales from kayaks through the ice with technology far superior to the Norse for that environment. The Norse, however, clung stubbornly to their identity as European pastoralists. Their social status and Christian identity were tied to their livestock and their stone churches, not to hunting seals. Archaeological evidence shows they continued to eat a diet heavily reliant on cattle and sheep, even as those animals grew scrawnier, while they largely ignored the rich marine resources the Inuit expertly harvested. This cultural inflexibility in the face of climatic change was a fatal mistake. As the cold intensified in the 14th century, the situation grew desperate. The last documented ship from Norway arrived around 1368, After that, the settlements were on their own. The Western settlement failed first, its inhabitants simply vanishing by the mid-1400s. The Eastern settlement held on a little longer, but the end came quietly. The last written record is a marriage recorded in the church at H. Valsey in 1408. By the middle of the 15th century, that settlement too was empty. When European ships finally returned centuries later, they found only ruins, the bones of malnourished cattle, and a profound silence. The Norse did not die in a sudden catastrophe. They were slowly squeezed out by a changing world. The Little Ice Age shortened their growing seasons, increased their isolation, and brought a competitor better suited to the new, colder normal. Their story is a poignant lesson in the fragility of human expansion. A civilization can ride a wave of favorable climate to the ends of the earth, but when that wave recedes, it can leave them stranded, their way of life becoming a relic in the very landscape they sought to conquer. The closing of that climatic window did not just end a colony, it ended an entire age of northern exploration, leaving the North Atlantic to the ice and the Inuit for centuries to come. The cold reached its modern zenith. From the 16th to the 19th centuries, the Little Ice Age tightened its grip, delivering a series of punishing winters that defined an era. This was the 30th and most recent Great Winter, a climatic event experienced within written history. Its fingerprints left not just in ice cores but in diaries, paintings, and government ledgers. The Thames River in London froze solid repeatedly, and during the coldest winters, the ice was thick enough to support entire fairs. Elaborate streets of stalls sprang up on the frozen river, with printers selling souvenir pamphlets, oxen were roasted on spits, and temporary pubs served ale on a pavement of ice. These frost fairs were spectacles of human merriment, but they were born of profound climatic severity. Across Europe, glaciers in the Alps advanced relentlessly, swallowing farms and entire villages. Paintings from the period, like those by the Dutch masters, frequently depict people skating on frozen canals that rarely freeze today, capturing a world consistently colder than our own. The impact was not picturesque, it was agricultural catastrophe. Growing seasons across the northern hemisphere shortened by weeks. Crops failed with terrifying regularity, leading to skyrocketing grain prices, widespread famine, and social unrest that simmered for generations. Then, in 1816, the weather delivered its most infamous blow. Across Europe and North America, summer never arrived. In June and July, snow fell in New England. Frost killed crops in August. This was the year without a summer, and its primary cause was not the slow orbital cycles of past ice ages, but a sudden, violent eruption. Mount Tambora in Indonesia had blown itself apart the year before, in one of the most powerful volcanic events in recorded history. The eruption injected a massive veil of sulfur aerosols into the stratosphere, reflecting sunlight and plunging the planet into a volcanic winter. The resulting global famine was immediate and desperate. In Europe, starving mobs rioted for bread. In the United States, the failure of harvests triggered a mass migration from New England to the more fertile Midwest. The crisis directly influenced culture as a group of writers, including Mary Shelley and Lord Byron, confined to a Swiss villa by the incessant rain, turned to telling ghost stories, leading Shelley to write Frankenstein, a novel born from a literal dark and stormy summer. This event proved that even in the modern age, humanity remained terrifyingly vulnerable to abrupt climate shocks. The cumulative pressure of these centuries of cold fundamentally reshaped societies. In France, the sequence of poor harvests in the 1780s, exacerbated by the Little Ice Age's pattern, led to bread shortages so severe they helped ignite the tinderbox of social inequality, contributing directly to the desperation that fueled the French Revolution. The cry for bread was not mere metaphor, it was the central economic reality of a population pushed to the brink by a failing climate. Meanwhile, in Britain, the cold provided a different kind of catalyst. As wood became scarcer and more expensive for heating, and as population growth strained traditional energy sources, the search for an alternative intensified. The answer lay underground in the vast coal seams formed by that ancient Carboniferous Ice Age. The need for warmth and mechanical power, amplified by the Little Ice Age's hardships, helped drive the adoption of coal-fired steam engines. The Industrial Revolution, in part, was a technological escape from environmental limitation, a burning of ancient sunlight to overcome a persistent modern winter. Globally, the cold forced adaptations. Communities in the Swiss Alps developed resilient land management practices and shared risk insurance systems that are studied today. The Norse colonies in Greenland, as we saw, succumbed, but the Inuit thrived, their technology perfectly adapted to the ice. The Little Ice Age's peak demonstrated a pivotal truth of the modern era. While climate could still devastate societies, those societies now possessed the technological and organizational capacity to engineer partial solutions, though always at a cost and never without leaving some behind. This 30th winter was the final great act of the Ice Ages, a farewell performance witnessed and recorded by a now global civilization. A stark reminder that our history has always been, and will always be, a dialogue with the cold. This persistent chill forced a quiet revolution in the fields, as traditional wheat and rye harvests faltered under the shorter, cooler summers. Europe faced a constant specter of famine. The solution arrived on a humble boat from the New World, the potato. Initially viewed with deep suspicion as a strange, dirty tuber, the potato's true genius was its resilience. It could grow in poorer soils, required less sunlight than grain, and yielded far more calories per acre. Its adoption, championed by figures like the French pharmacist Antoine-Augustin Parmentier, was slow and fraught with superstition, but ultimately hunger won. By the 18th century, the potato had become the bedrock of the European diet, particularly in Ireland, Germany, and Eastern Europe. This single crop, a gift from a warmer continent, stabilized populations against the Little Ice Age's worst blows, allowing societies to grow even as the climate remained unforgiving. It was a dietary adaptation born of necessity, a biological buffer against the 31st winter's bite. The mood of the era was painted in frost and shadow. The gloomy, tempestuous weather of the Little Ice Age seeped into the very soul of European art and literature, giving birth to the brooding aesthetic of the Romantic period. This was no coincidence. Artists like Caspar David Friedrich did not simply imagine their sublime, melancholic landscapes, they lived them. His paintings of lone figures gazing upon mist-shrouded mountains and frozen seas, such as the Wanderer above the Sea of Fog, directly mirror the experience of a world where nature felt vast, unpredictable, and overwhelmingly powerful. The chilling beauty of a glacier, the terror of a storm at sea, these were not just themes, they were daily realities. In literature, Mary Shelley's Frankenstein, conceived during the Year Without a Summer, is a story literally born from darkness and confinement, its themes of monstrous creation reflecting a deep anxiety about humanity's place in a hostile natural world. The Romantic obsession with ruins, wildness, and elemental force was a cultural echo of the climatic instability outside the window, a collective shiver translated into canvas and verse. Meanwhile, the cold helped stoke the engines of empire. As resources grew strained at home, the drive to secure warmer climates and new commodities became a matter of economic survival. The Little Ice Age created a powerful push-pull effect on European colonial expansion. The push came from hardship, competition for dwindling agricultural yields, and the need for lucrative goods like spices, sugar, and cotton to fund states buckling under climatic stress. The pull was the allure of the tropics, lands seemingly untouched by the northern freeze, where plantations could flourish year-round. The scramble for colonies in the Caribbean, South America, and later Africa was in part a geographic escape from environmental limitation. Nations like England and the Netherlands were not just seeking wealth, they were building climatic insurance policies, outsourcing their agricultural and resource needs to latitudes where the sun still reliably shone. This expansion, brutal and transformative, reshaped the globe's demographics and economies, creating a world system where the temperate zone's crisis was answered by the exploitation of the tropics. The final Great Winter, therefore, did not just change how people ate or what they painted. It fundamentally altered the map of power, proving that the search for warmth could be one of history's most relentless and destructive forces. So the pattern is laid bare across 30 chapters of deep time, from the Huronian freeze that oxygenated our air to the Little Ice Age that inspired Frankenstein. A single, relentless driver emerges. It is not the ambition of emperors, the clash of armies, or the brilliance of philosophers that has most consistently steered the course of human destiny. It is the climate, more specifically, it is the cold. These 30 great winters reveal that cooling events, these planetary shivers, have acted as history's ultimate architect, the invisible hand that shapes the rise and fall of everything we build. Think of it this way: kings declare wars, but it is a failed harvest that makes a population desperate enough to revolt. Philosophers write manifestos, but it is a changing landscape that forces a society to invent new ways to survive or perish. The climate is the great stress test, the ultimate bottleneck through which all human ambition must pass. It does not dictate our every action, but it sets the board, defines the rules of the game, and relentlessly reshuffles the pieces. When the world cools, it compresses, habitable land shrinks, resources concentrate, and people are forced together into tighter spaces. This compression is the mother of invention, but also of conflict. It drove our ancestors to refine stone tools into works of art in the Solutrean caves, and it pushed Viking longboats across an ocean suddenly free of ice. Yet that same pressure, when it becomes too great, is also the engine of collapse. It starved the pharaohs of the Old Kingdom when the Nile failed, and it emptied the mighty cities of the Indus Valley when the monsoons shifted south. Climate change, especially these cooling phases, is the great disruptor. It breaks apart stable systems, whether those systems are ecosystems, economic networks, or entire empires. The collapse is often tragic, a story of famine and loss, but in the shattered silence that follows, something new always stirs. The Dark Ages after the Bronze Age collapse were not an empty void, they were a necessary clearing, a fallow period where the rigid hierarchies of palace culture gave way to the scattered, experimenting communities that would eventually forge classical Greece. The climate's winter forces a societal reboot. It wipes the slate not clean but clear enough for new scripts to be written. This is the cyclical heartbeat of our story: freeze and thaw, collapse and rebirth, pressure and adaptation. Our intellect, our technology, our social structures, even our myths and art, bear the unmistakable imprint of this dialogue with the cold. We are, in a very real sense, children of the Ice Ages. Our history is not a straight line of progress, but a complex dance with a volatile planet, a dance where the climate always leads. The echoes of those 30 winters are not confined to the past, they are the urgent background hum of our present moment. We stand now at the precipice of a new kind of climatic shift, one with a distinctly human fingerprint. For the first time in Earth's long history, a single species is not merely adapting to a changing climate, but is the primary driver of that change. This era, the Anthropocene, is our own human-made ice age in reverse, a rapid warming event where the pressures are not of encroaching glaciers, but of rising seas, supercharged storms, and shifting agricultural zones. The ancient patterns, however, remain eerily familiar. We see the same stressors that toppled empires now appearing on our own horizon. Food insecurity from disrupted growing seasons, mass migration as regions become unlivable, and social unrest fueled by resource scarcity. The 4.2 kiloyear event that starved pharaohs was a drought lasting centuries. Today we face a global atmosphere holding more moisture, leading to both deeper droughts and more intense deluges. a paradox of plenty and peril that strains our modern infrastructure just as it strained ancient irrigation canals. The volcanic winters that brought famine and plague demonstrate how quickly a climatic shock can unravel complex systems, a lesson for our own globally interconnected supply chains vulnerable to a single disruption. And the story of the Norse in Greenland is perhaps the most haunting parallel of all, a warning about cultural rigidity. They clung to an identity as European pastoralists even as their environment transformed around them, refusing to adopt the sustainable hunting practices of the Inuit who thrived in the new cold. Are we, in our reliance on fossil fuels and industrial agriculture, clinging to a similarly unsustainable identity as masters of a stable planet that no longer exists? The past offers no single blueprint for survival, but it does provide a stark menu of outcomes. Some societies, like the Magdalenian hunters, built resilience through far-flung trade networks and shared knowledge, creating a safety net across a continent. Others, like the Indus Valley civilization, managed a strategic retreat, dispersing and adapting their way of life rather than fighting a losing battle against a changing landscape. And some, like the kings of Akkad, faced total collapse because their centralized, brittle systems could not withstand the shock. The critical lesson is not in the specific technology, but in the mindset. Resilience in the face of climate change has always depended on three pillars: diversification, flexibility, and cooperation. Diversification means not putting all your eggs in one basket, whether that basket is a single crop, a single energy source, or a single economic model. Flexibility is the willingness to change course, to abandon cherished practices when they no longer serve survival, to learn from others who are adapting successfully. And cooperation is the understanding that a crisis that transcends borders cannot be solved within them, that the old rivalries must give way to shared survival, just as distant Magdalenian groups traded precious materials to ensure mutual survival. Our modern global civilization is the most complex and interconnected society ever to face a climate transition. We possess tools the ancients could never dream of: satellite monitoring, climate models, renewable energy technologies. But we also face challenges of scale they never did. The question hanging over us is not one of capability, but of collective will. When the next great winter, this human-made summer of extremes, tests us, will we be the society that innovates and cooperates, building a new kind of resilience? Or will we be the one that fractures, retreats into fortress mentalities, and allows our short-term divisions to dictate a long-term decline? The ice ages show us that climate is not just weather, it is destiny. For the first time, we are holding the pen that writes that destiny. The next chapter in this 30-part story is ours to author. From the primordial freeze that filled our skies with oxygen to the volcanic winter that birthed a monster in Mary Shelley's mind, this 30-act drama reveals a truth both humbling and empowering. Our story is not one of conquest over nature, but of profound conversation with it. Each great winter, from the billion-year chills to the centuries-long freezes, served as a ruthless but effective teacher. It pushed our ancestors to the brink, forcing evolution's hand, sparking desperate migrations across frozen bridges and stormy seas, and compelling innovations that range from the stone-tipped spear to the coal-fired engine. These cold snaps were the ultimate catalysts, the pressure that turned carbon into diamonds and apes into architects. They toppled empires that grew too rigid, like Akkad and Rome, and scattered the seeds of new ones like the city-states of Greece. They are the reason we farm, the reason we trade, the reason we tell stories of floods and frost giants. Our civilizations are not built in spite of the climate. They are built in direct response to its every shudder and sigh. This enduring dance with the cold is the deepest rhythm of our history, a reminder that we are not the masters of this planet, but its most adaptable students. The ice ages sculpted our world, our biology, and our societies, proving that change, however brutal, is the only true constant. So as we face a new chapter of climatic transformation, we carry with us the legacy of 30 winters, a genetic and cultural toolkit forged in frost. Which of these epic transformations left you most in awe? Was it the desperate birth of agriculture in the Younger Dryas or the maritime courage that peopled Sahel? Share your thoughts in the comments below, and if you enjoyed this journey through the deep time mysteries that shaped us, subscribe for more explorations into the hidden forces that